Dun 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 dun. In the future, we're going to be talking about how we do pooled tests here. So we're going to compare cyclists and runners, and can we see whether there is a difference on average for how much they can bench press? Right now, we would have a problem because we only have 10 cyclists. Altogether, we have 55 people. We have a lot of runners. That doesn't matter. One of the groups is below 30. That means it would be cannot do unless I assume normality. What kind of test is this? Is there something linking the first cyclist to the first runner? Were they like the same person on an exercise diet cycling? No, they're really not. So this is not matched pairs. So this matched pair standard deviation is useless. We're not going to need or want him. There is a spot where it says assume they have the same standard deviation. That's what leads us to do a pooled test. If you're interested, you could use this data to incorrectly do the independent test, where we keep the standard deviation separate, the 18 and the 15. The only reason I bring this up is because it would lead to fail to reject, and we're going to see the answers actually different for the pooled test. Usually they're pretty close, so it's rare to get an example that's different. I specially made this one to come up with a different example if you correctly do pooled test the way it should be. So let's do this in pieces. What are we testing? Cyclists bench more than runners, which looks like a greater than test. Is this going to be the null or the alternative? It has to be the alternative because there's no equal sign. So now I can fill in the null, and this also tells me I have a right-tailed test. And usually you would subtract this to the other side so that you can see the zeros. But none of this is any different than what we've already been doing over and over. So the pooled test isn't changing any of that structure or setup. It's when we go to calculate the t-score, we're going to need that pooled standard deviation, which feels like this awkward pause in the work we were doing. Whoa, we've suddenly got to calculate this guy. If I wanted to put it in my calculator all at once, I'm going to have a lot of parentheses going on to keep the n-1, to keep the numerator, to do the square root of the whole thing. Although if you do a few things in your head, you can make this look at least a little bit better, since n-1 isn't hard to do. But if you worry about that, then just do it in pieces, and you should get an answer of 15.55. Quick reality check, does that seem reasonable? It's between the 15 and the 18, a little closer to the 15 side. Yeah, this looks good. Now I can finish the rest of my hypothesis test, where we make sure that the 15.55 is what goes in both places for the standard deviation. Degrees of freedom are the degrees of freedom for both groups added together. The 9 and 44, that's how I get 53. Then I go to the applet. I go to T, put in degrees of freedom, which was 53. I have a t-score of 1.839. It is a right-tailed test, and there's my p-value. Put in our small p-value to reject the null, and we conclude that cyclists can bench press more. See, I told you this was an example where it actually would change the answer. Everything here, though, is stuff we've practiced and that you should be familiar with the exception of right here, pausing to get a pooled standard deviation, putting that in the t-test, making sure your degrees of freedom have pooled together from both samples, and the rest of it works the same.